The problem we are trying to solve in our project is how to find peaks in brain activity data. Peaks refer to the times at which the amplitude of the voltage recorded by the EEG test was the highest. To demonstrate our program, we used a random EEG waveform generator provided by Oxford University. The model provides the user with a series of functions that can be combined in a simple MATLAB script to create a random EEG waveform of any desired length and number of peaks. As we can see in our script, we chose to generate a signal that's 100,000 data points long with 100 random peaks. This is how the signal looks like plotted over time. In our program, we demonstrate how using a max heap provides a way to find the peaks in the EEG data in a much more computationally efficient way compared to using a simple Python list to hold it. Our heap class is stored in a separate Python file and contains all the necessary functions needed to maintain the data in sorted order that allows us to extract the max values with O of log n time complexity. We have heapify up, down, insert data point, and extract max functions, which is all that's needed to accomplish our goal. Then in the main program, we have CSV to list and CSV to heap functions that load the data from the CSV file into the chosen data structure. Finally, we have simple UI that allows the user to determine how many peaks we want to extract and what data structure we want to use. Let's run the program. The user is provided with the choice to load their own dataset, and if no dataset is provided, then the program will use the randomly generated one by default. As we can see, we also have an option to detect peaks using the Python list or using the heap. Let's start with the first option. Let's choose to extract 10 largest peaks from the signal. As we can see, the time taken for that action to be accomplished was 0.32 seconds. Now let's do the same thing, but using a max heap. As we can see, the peaks were found much more efficiently in a much shorter time. We can save our results to a txt file using option 4. Here, the peaks were saved using an accessible format that can be used to further process the data.